Hello, in this video we're going to take a look at volume of cylinders starting on page 550 in your workbook. So as we've learned, a cylinder has a base that is a circle, and the cylinder also has the height which reflects the rectangle. And so when we look at how we calculated volume of prisms, we had to multiply area of a base times the height. And so volume of cylinder is no different. We're going to take the base, which happens to be a circle, and multiply it by the height. And so when we look at the formula involved, we're going to use pi r squared to get the area of our circle and multiply it by the height of the cylinder. Good rule of thumb whenever you're looking at a figure is to make sure that you have all the information you need. And here we do indeed have the radius provided to us, and we also have the height. So we're ready to go. We're going to calculate the volume. We're going to do pi r squared, the area of the circle, multiplied to the height, and we can go ahead and for this example, I'm going to use my pi button. So I'm going to take 11 squared on my calculator first and then multiply it by my pi button. So 11 squared multiplied to pi gives 380 and quite a long decimal. So I'm just going to reflect that to the hundredths place, 0.13. And then I'm going to multiply that by 13. So for the area of the circle, we're at meters squared. Multiplied by meters, we're going to get cubic meters as our answer. So we're taking a look here at 4900, so 4,941.69 cubic meters. And if we wanted to round this, we could round it to the tenths place, which would go to 0.7, or we could round it to the whole number. I'm going to leave it as it is. 4,941.69 cubic meters is the volume of this cylinder. When you have an application problem, it's really a good idea to draw a picture. That way you can label your picture and get all the information down. So a paint can has a diameter of 25 centimeters and is 40 centimeters tall. So I'm going to draw this paint can best I can. And so I'm going to label it. 40 centimeters is the height, and the diameter all the way across is 25 centimeters. How much paint is there in the can if it's 40% full? What we can do here is we can determine how much is in there if it's 100% full first, and then we can calculate 40% of that. That would be a good strategy. What we have here is a diameter, and we need the radius. So we're going to cut that diameter in half by taking 25 divided by 2. So our radius is 12.5 centimeters. So let's go ahead and calculate 100% volume. So we're going to take our formula, pi r squared, multiplied to the height. And again, I'm going to use my pi button. I'm going to take the 12.5 squared first, multiply by pi, and then multiply by 40. When we go ahead and plug in all those numbers in our calculator, we're going to get 19,634.95, a little bit more, but I'm going to round to the hundredths place there. That is cubic centimeters of volume. That's 100% full. At this point, we can determine 40%. There's some options. If we want to do 40%, we can take that value, 19,634.95, and multiply it by 0.4, which is 40%. Or if you'd prefer, you can set up a percent proportion. So we can say that 40% out of 100 is equal to X over 19,634.95. Either way, you're going to be calculating 40% of that volume. I'm going to go ahead and do the decimal multiplication. And so we come to 7,853.98. Cubic centimeters is where we're at if that paint can is 40% full. And again, we could round depending on the question if it's asking us to round to a certain place value. Remember that if you set up a proportion, your method is either quickly to cross multiply and divide to solve for x, or you can find your cross products. So you could cross multiply 100 times x is equal to 40 times the 19,000. And then again, you would isolate x through the division. So you would divide by 100 and divide by 100. And you would get 40% that way. So you have some options when you're calculating percentages in a word problem. For the student example, we have a different word problem. A circular swimming pool has a diameter of 6 meters and a depth of 2 meters. So I'm going to start to draw the picture of the circular swimming pool. And so I'm going to label it. The diameter all the way across is 6 meters, and the depth, which is also the height, is 2 meters. If the water level is 50 centimeters below the top of the pool, how much water is in the pool? So actually the water is not right up to the top, as we know for swimming pools. There's going to be water that's displaced when people jump into the pool. If there's too much water, the water is going to spill over the top. So we're looking at taking away that 50 centimeters. You may have noticed right away that we have different units. So probably the best way to go about this is to convert the centimeters to meters, as our other measurements are in meters. So 50 centimeters converted to meters is 0.5. We're swinging 2 decimal places over to the left. So 0.5 meters. So we need to take that away. So the actual height that we're going to calculate is not 2 meters, but 1.5 meters. We're going to take that 2 meters minus the 0.5, giving us the 1.5 meters as our new height. Remember that the diameter is 6 meters, which means the radius is half of that, which is 3 meters. So we had to do some initial work here to get the numbers that we need. Now we can calculate the volume. The volume is the area of the circle multiplied to our height, and we're going to use pi multiplied to 3 squared, and then multiply that by 1.5. So we go ahead, 3 squared is 9, multiplied to pi, multiplied to 1.5. Our volume is 42.41, and I'm going to cut the decimal off there at the hundredths place again. And this is going to be in meters cubed for the swimming pool. Now you're ready to practice the exercise questions on page 552 and 553 in your workbook.